We're going to talk about agents and tools that can be used to augment large language models today. So far, we have been talking about agents in a very limited way. Agents are no more than a piece of software that passes prompts from the user to a large language model and then return the results back from the large language model back to the user. In the last video, we said, hey, what about if we abstract out the large language model as something that is just a tool, just like other types of plugins? Or if we could also add memory, then the agent would be a lot more powerful and a lot more human-like. So it turns out this idea has been expanded in a variety of ways, including back earlier this year in 2023, OpenAI launched its plugin ecosystem with a few plugins. But of course, now, when you are watching this video, this ecosystem has grown significantly more than the dozen or so that it launched. Also, part of what we're going to cover today is some academic research, in fact, advances in how agent reasoning or AI reasoning in general and planning can be done. And here is an Eichler 2023 paper on a very famous reasoning module called REACT, which stands for Reasoning and Action, that we're going to try to implement today with the help of LangChain. And in particular, we're going to enhance our chatbot agent, Sydney, with tools such as Google Search, DALL-E image generation, news, Python REPL, weather, Wolfram Alpha, and a variety of other tools. So let's get to it. Here's our chatbot repository. Let's take a look. There is a new requirements.txt file that has a few more modules. So first thing we want to do is to make sure that in the environment, in this case, we call it the Gen AI environment, in the environment that you're operating in, let's make sure to install -r requirements.txt, and this should implement all the required packages that are needed for our application. Let's now create the project. So we're in the chatbot directory. Let's now create a new 04 underscore, let's say, agent. And then let's go into 04 underscore agent, make our usual two folders, which is one is notebook and the other one is SRC. And let's open up our favorite editor. In this case, we're going to use Visual Studio Code. And now we're ready to go. So now let's go and create the first one. Let's call this is our Sydney. Chatbot.py. And now we're ready to go. All right. Let's now first move this file into our SRC folder if it's not already there. And then let's do the first things that we usually do when we create a large language model file here, which is to load in the environment variables. So just to remind everyone, essentially what this python.inf package does is to automatically discover environment variables that are stored in your local.environment or .inf file. For more details, please see our video number 1 for explanation about this. Once that's done, we now need to kind of decide on what is the actual language model we're going to be using. So in this case, we're going to use a chat model. And as of 2023, the one that is recently priced and still have good performance is GPT 3.5 Turbo. So we'll do that. After that, we now need to import a bunch of libraries so that we could use these libraries, such as the Changlit library for creating the chatbot web experience, and then a bunch of LangChain libraries for chat models. And then what is new is we are going to be using its submodules called agents, along with a bunch of tools. And then we're also going to be using the Dolly image generator later. That is going to be hopefully the wow factor in this video. And then finally, we will be implementing a memory that's called a conversation buffer memory that has a first in, first out kind of characteristics after the buffer size is reached. Okay. Now, let me first introduce something called tool names. So the way that we're going to identify various tools that are available is through the use of special names, such as there are the News API, there is the Request API, there is the Google Search API, and then the Dolly image generator tool. Now, if it turns out some of these tools requires you to go into their site to get specific APIs, such as the News API, feel free to search for news-API and go get yourself news_API_key and put it into your local.inf file. Similarly, Google Search requires you to get 2 special API key. Same thing for Dolly image generator, which uses your OpenAPI key. Wolfram Alpha also requires a special key that you need to go get from the Wolfram Alpha site. Okay, now let's create the language model that we'll be using. So as we mentioned, we're going to be using the chat OpenAI model. And the model that we'll be using would be the model name that we have specified earlier, which is GPT 3.5. And to eliminate hallucination, let's make sure to set the temperature to something close to 0. So let's do it at temperature 0 for now. Next, let's create a memory for the large language for our local agent to store interactions with the user. In this case, we have mentioned we'll be using the conversation buffer memory. And let's specify a specific key for it in case we want to get access to it. Let's call it chat history. And then we also want the output that is returned from the large language model to be stored. So let's store the return messages and set that to be true. Now, we're going to now load the tools that we have specified above. So let's call this the load tools method, passing the tool names that we have created. And the large language model that will be using this tool to be the large language model. And then for one of the APIs, which requires a special API key, we're going to specify. So this is a variable key argument, key value pair argument. That's going to be the API key that we retrieve from the News API site. Finally, it's now time to create the agent that we're going to be using with. So in this case, the agent that we'll be using, we're going to initialize the agent with the set of tools that are available. And the large language model will be large language model. And the memory would be the memory that we have created. The specific agent that we want, so rather than typing out this, there is a special enum constant agent type. And the one we'll be using, there are a couple of them here. We're going to be using the conversational React agent. The zero-star agent is for the non-chat version, and the structured chat requires some sort of a semi-structure like JSON for interaction. So we'll eventually touch base with these other two, but for now, we're going to be using the chat conversational React description agent. Here we want to see everything, so let's make sure that we set the verbose to be true. And then finally, we would like to handle any sort of error here. So it's called the handle parsing errors. Handle parsing errors. And we're going to set that to be true. That will be the end. So this is an React agent that uses the description of the tools to decide what kind of tools that are most appropriate. And it will handle any sort of error that is passed by from the large language model gracefully, or somewhat gracefully. And it uses a particular memory that it will have set up. It is a chat OpenAI model using the tools that are available to it. So this is in a single method call. The LangChain environment allows us to create an agent that basically implements the React conversational agent style that we have been talking about. All right. As usual, we now need to set up the chatbot start and chatbot main method. For Chenglit, as we are writing this particular session, there is an updated change to the interface of Chenglit. So everybody pay attention. This is a little bit different than what we have talked about in the first video. So we have said there are two kinds of method that we need to create. The first is an async def main method that would handle any sort of ongoing interaction with the user. And the other is an async def start method that basically would be welcoming the user the first time that we have started the chatbot. And so now let's first implement the start method, which basically is the same because it's an async call. We need to await the message with a particular content that welcomes the users, such as, hello there, I am Sydney. How are you? And then we will send that. So that's basically the same. And we need to decorate this with on-chat start. Now, what is different is for the ongoing main method for interacting with the user. Now, the decoration remains the same, which is this is a on message. But in order to receive the right message, the message now is no longer a string type, but is instead now you have to specify the Chenglit message type. That's the main difference. With that now set, let's set the response to be whatever it is that we're going to generate. And then we're going to send it back to the user, co.message, with the content being that particular response that we're going to fill in and send. So now we are ready to do the first testing to make sure that the framework, the skeleton is set up properly. Now let's fire up our Chenglit, make sure that we are in the right directory and we have access to the Sydney chatbot. Let's now fire up Chenglit, run, SRC folder, the Sydney file, -w. The -w would auto reload whenever the file, the source file changes. So this should be the only time that we fire this up. All right. So we are now being welcomed by Sydney, which is great. I am well. How are you? Now, at this point of the skeletal program, we don't expect any return, but let's take a look. And as expected, nothing is returned because we haven't done anything yet. Getting back to the source code, the reason we haven't done anything is because in the actual main response, we have not really filled in what the response needs to be. Well, the response is going to be something that the agent does So in this case, we need to put the whatever it is that the agent does into the try and catch or try and accept clause here. And then we're going to do a try except. And in case there's any exception, we would like the response to be, sorry, I have an internal error. Okay, that's pretty good. Now, if there's no error, we want the response to be that the agent would have run my message.content. So this is relatively different than the last time we have done this. Previously, message itself is a string. Now it's of type chainlet message. And in order to get the actual message from whatever the user has typed in, we need to use this message.content accessor. Okay, we're now ready to test this again. Now we are back with our browser, except at this time, we have also opened up the command shell, or the PowerShell in this case, because we would like to take a look how Sydney actually thinks as we ask different questions. I am well. Let's say I am curious about how big the Earth is. Let's take a look on the left here. As Sydney is thinking, it is now actually contacting Wolfram Alpha to find the size of the Earth. Now, apparently, Wolfram Alpha has a lot of content here. And in this case, as a database, it returns back it is however number of miles. So my guess is that it's probably true. Now let's test the memory part of this without having to repeat our question. Let's say, can you look up how fast a Boeing 777 plane can fly, and how long does it take to circumnavigate the Earth once? Let's look at the left here. First, it is searching, do a Google search to find the answer to how quickly the Boeing 777 can travel, which is maximum speed 590 miles per hour. The time it takes to circumnavigate the Earth, its calculation would depend on the various factors such as wind condition, flight route, but it would typically take 15 to 16 hours. To be honest, it surprised me a little bit. That is quite fast. So I guess at this point, we'll have to ask you to verify this to see if our Sydney here has tricked us or has done miscalculations. So now, this is pretty impressive. So what you are looking at is not only an interaction with a large language model. It is now you are interacting with an artificial agent, software agent, that makes use of various tools, whether it is the Python tools that is available, or Wolfram Alpha, or Google Search. And coming up next, let's figure out how to make this agent able to use a tool to generate images for us. All right, we're now back to the source code for the Sydney chatbot. Now, in order to use this Dolly image generator, Dolly happened to be a tool, an image generator tool by OpenAI. All you need to do is to have your OpenAI API key in the environment variable, and then we are ready to go. So we now first need to figure out from the actual message itself, once we have asked the ChatGPT model to create an image, how do we know the response will have an image? So coincidentally, there is a convenience method that we have imported from LangChain utilities called a Dolly image generator, and has a Dolly API wrapper. Essentially what this does is it could parse the output from the user, and it would try to interpret to see whether there is an image that can be generated from the response. So let's take a look at how this works. So let's say the image URL here that we would like, we want to use the Dolly API wrapper. We would like to run that against the response that we got back, assuming that the response has no error in it, right? Otherwise, we'd get into the try and accept the accept clause here. Now, we now need to check if the image URL is not null, right? Then we would like to add something to the HTML element of the page. So how do we do that? So it turns out there's this very elegant solution provided by the Chinglet library, which involves setting a set of elements that you would like to display to the user. And in addition to the content that we return back to the user, we could tell what other elements we would like to display. So in this case, if the image URL is not null, then we would like one of the elements to be a image whose name is, let's say this is our generated image. And the display, we would like it to be inline. In other words, we don't want it to pop out. Instead, it is in the chat itself. And the specific URL is simply this image URL. And that really is it. Let's give it a try on how this could look. We're now back to our web browser. Now, because once we have saved, because we have used the W-W option for running Chinglet, it automatically reloaded. So now, hi there, I'm Seti. How are you? I am well. Can you generate an image of a beautiful sunrise over a lake? On the left-hand side, you can see that the agent is now calling the Dolly image generator. It has generated an image. Now the question is it now able to be displaying in our front end? So I think it is trying to retrieve the image right now. And ta-da! That is a pretty amazing sunrise over a lake. And there you have it. That's hopefully pretty cool exercise for all of you. Now, go forth, play with this code, and see what else you could create in terms of this image generator, as well as exploring how to use the other tools that are available in this agent. Congratulations. This is quite an accomplishment.